Good morning to one and all. My name is D. Kiran Kumar Reddy, bearing roll number 244G18045 from ECE department. My topic is first order stationary process, second order stationary process, and wide sense stationary process, and stacked sense stationary. Introduction to stationary process. This presentation explores key concepts in stochastic process theory related to stationarity. Understanding stationarity helps simplify analysis and modeling of time series data. We, we will cover first order, second order, Weinstein's, and strict stationarity types. First order stationary process. A process is first order stationary if its means remains constant over time. The mean function does not depend on the specific time index. This property ensures the process average behavior is time invariant. Second order stationary process. Second order stationary requires the mean to be constant and the autocovariance to depend only on lag, not on time. The autocovariance function is symmetric and depends solely on the lag between observations. The assumption simplifies analyzing the dependence structure of the process. Wide sense stationarity. Wide sense stationarity combines first order and second order stationarity. A process is wide sense stationarity if both mean and autocovariance function satisfy the stationarity conditions. Wide sense stationarity is a common assumption in signal processing and time series analysis because it simplifies spectral analysis. In-order stationarity. In-order stationarity extends the concept to higher moments, requiring all moments up to order n to be time invariant. For example, second order n equals to 2 involves mean and autocovariance, while third order also consider a sequence. N-order stationarity is useful for analyzing processes with more complex statistical properties. Strict stationarity. A process is strictly stationary if both joint distribution is invariant under the time shifts. This means the joint distribution of any set of observation does not depend on the specific time points. Strict stationarity is a stronger condition than weak stationarity. Differences between wide sense stationarity and strict stationarity. Wide sense stationarity focuses on mean and autocovariance, which are second order properties. Strictly stationarity involves all joint distributions, making it a more compressive condition. May real world processes are well wild sense stationarity but not strictly stationary due to higher order structure variation. Practical implementation of stationarity. Assume stationarity simplifies modeling, forecasting, and spectral analysis of the time series. Stationarity assumptions are crucial in main statistical methods such as ARMA modeling. However, verifying stationarity in real data requires careful testing and sometimes transformation. Summary and key concepts. First order stationarity concerns constant mean. Second order adds autocovariance depends only on lag. White stationary encompasses both mean and autocovariance invariance. Strict stationarity involves invariance of the entire joint distribution, making it in the most compressive form. Conclusion and further reading. Understanding different types of stationarity is essential for proper time series analysis. Recognizing the assumption behind each stationarity type helps in choosing appropriate models. For more detailed information, consult advanced text on stochastic process and time series analysis. Thank you.